Now, so far when we've talked about finding these trig values of an angle, the circle that we drew around the angle could be any size we wanted. We saw that on the very first day. Whether you draw a really big circle or a really tiny circle, you get the same result for the angle, and so you would get the same result for all of these fractions. If you draw a big circle, you're going to have a big numerator and a big denominator. If you draw a little circle, you're going to have a little numerator and a little denominator, and it's all going to work out to be the same fraction. Now, because of that, a lot of times, mathematicians decided things would be way easier if we could make the radius always be the same. And the simplest number mathematicians could come up with was 1. And so for that reason, we want to know, how do you take any old picture and turn it into a picture where the radius is 1? Well, that works out to be pretty simple, actually. So let's take a quick example. Let's suppose that for this particular picture, the x is 5 times the square root of 3, and the y is 5, and the radius is 10. So those are the signs. Well, you can very easily take this picture and convert it into a picture where every part is shrunken. So this time, and these are not to scale, that radius over there is 10. This radius over here is going to be 1. These are obviously not to scale. That picture is supposed to be 10 times as big as this picture, but if I drew this 10 times smaller than that picture, it would be so tiny you couldn't see it. So these are not to scale. But how do we rescale? What should I do mathematically so that that 10 becomes 1? Well, the easiest way to turn this 10 and rescale into 1 is if I divide by 10. So 10 divided by 10 equals 1. And so now I'm going to do the same thing with each of the other parts. So the radius, the old radius was 10, but I'm going to divide it by 10 and get a new radius of 1. The old x was 5 times the square root of 3. I'm going to divide that by 10. Well, 10 goes into 5 2 times. So I get that the new x is square root of 3 over 2. So x now is square root of 3 over 2. And then what about y? Well, the old y was 5, and I'm going to divide that by 10, so my new y is 1/2. Now, why would mathematicians even care about this? Well, so many of these formulas over here have r in them. They decided it would be a lot easier if r was 1, that would make these formulas easier. So for instance, I want to find the sine of this angle. Well, that is y divided by the radius. Y is 1/2, the radius is 1. Well, what do you get when you divide by 1? You get the same thing. So sine of theta is y 1/2 divided by 1. 1/2 divided by 1 is 1/2. That's easy. That's easier to divide. And what about the cosine? It's supposed to be x over the radius, but again, the radius is 1, so I have square root of 3 over 2 for x over 1. Cosine of the angle in this picture is square root of 3 over 2 divided by 1, square root of 3 over 2. And what about the tangent of the angle? Well, the tangent of the angle is y, which is 1/2, divided by x, which is square root 3 over 2. Now, how do you divide a fraction by a fraction? You flip and multiply. So I have 1/2 times 2 over square root 3. You notice the 2's cancel out. And I get 1 times 1 is 1. 1 times square root of 3, square root of 3. Oh, wait a minute, I'm not done though, am I? Because I'm not allowed to leave roots in the bottom. Okay, that's all right, I can fix that. We can fix that. We just have to multiply top and bottom by square root of 3. So multiplying top and bottom by square root of 3, I have 1 times square root of 3, which is square root 3, over square root of 3 times square root of 3 is 3. There's our tangent, square root of 3 over 3. what if I want to get the cosecant? The cosecant of theta is r over y, radius which is 1, over y which is 1/2. Well, again, we have fraction divided by fraction. So I have 1 divided by 1/2. That's flip and multiply. So 1 times 2 over 1 gives me 2. The cosecant is 2. What about the secant? The secant of the angle is radius over x, so 1 over square root of 3 over 2. 1 over square root of 3 over 2. Dividing by a fraction again, so we flip. 1 flip times 2 over square root of 3 gives me 2 over square root of 3. Multiply top and bottom by square root of 3 because I can't leave roots in the denominator. I get 2 square root of 3 over square root of 3 times square root of 3, 3. And finally, cotangent of theta is x over y. So x square root of 3 over 2 divided by y, 1/2, gives me fraction divided by a fraction, square root of 3 over 2, times reciprocal, 2 over 1, flip and multiply. The 2's cancel out and become 1, so I have square root of 3 times 1, over 1 times 1 is just the square root of 3. Now, there are a large number of very special angles for the unit circle, and we're going to look at those in more detail together in class.